Okay, good morning, dear students. Welcome for the physics class. So, in the previous class, we have studied up to Newton's first law of motion. So, what do you mean by, or what it states? So, Newton's first law of motion, also called as a what law of inertia. Law of inertia. So, here it states that a body continues in the state of rest or in a uniform motion along a straight line unless it is acted upon by an external force. ಯಾವುದೇ ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ಅದ್ರ ಮೇಲೆ ಹೊರಗಡೆಯಿಂದ ಫೋರ್ಸ್ ಆಕ್ಟ್ ಆಗುವವರೆಗೂ ರೆಸ್ಟ್ ಒಳಗಿತ್ತು ಅಂತಂದ್ರೆ ರೆಸ್ಟ್ ಒಳಗೆ ಕಂಟಿನ್ಯೂ ಆಗ್ತದೆ, ಅಥವಾ ಯೂನಿಫಾರ್ಮ್ ಮೋಷನ್ ಒಳಗಿತ್ತು ಅಂತಂದ್ರೆ ಅಲಾಂಗ್ ಸ್ಟ್ರೇಟ್ ಲೈನ್ ಯೂನಿಫಾರ್ಮ್ ಮೋಷನ್ ಒಳಗಡೆ ಇರ್ತದೆ ಅಲಾಂಗ್ ಸ್ಟ್ರೇಟ್ ಲೈನ್. ಓಕೆ, ಯಾವಾಗ ಹೊರಗಡೆಯಿಂದ ಅದ್ರ ಮೇಲೆ ಫೋರ್ಸ್ ಆಕ್ಟ್ ಆಗ್ತದೋ ಅವಾಗ ಆ ಸ್ಟೇಟ್ ಚೇಂಜ್ ಆಗ್ತಾವೆ. ರೆಸ್ಟ್ ಒಳಗಿದ್ದು ಇಟ್ ಮೇ ಮೂವ್ ಆ್ಯಂಡ್ ಯೂನಿಫಾರ್ಮ್ ಮೋಷನ್ ಒಳಗಿದ್ದು ಮೇ ಎಕ್ಸಲರೇಟ್ ಆರ್ ಇಟ್ ಮೇ ಕಮ್ ಟು ರೆಸ್ಟ್. ಓಕೆ, ಇಟ್ಸ್ ಅಬೌಟ್ ದಿ Newton's first law of motion, or the law of inertia. Next we have inertial frame of reference, okay, or inertial frame. Inertial frame. So what do you mean by the inertial frame? So the frame in which the Newton's first law is valid are called as inertial frames. Okay, the frames in which Newton's first law is valid are called as inertial frames or inertial frame of reference. Okay, so here in the inertial frame, the force measured is equal to the actual force acting on the body. Remember this point? So inertial frames means here the force measured force is equal to the actual force applied on the body. Is it clear? How? Let me take an example. Consider a person who is standing inside the stationary lift. Standing inside the stationary lift, or a person is standing in a lift moving with a uniform velocity. Lift should be rest, or else the lift should be moving with a uniform velocity. Then whatever force means here, force means weight, his weight. Okay, so here the measured weight and the actual weight are equal, right? Yes, measured weight and actual weights are equal. Is it clear? So this is an example for inertial frame. So the inertial frame of reference. So here these are the frames. These are the frames in which Newton's first law is valid. Okay, and here the measured force is equal to the actual force acting on the body. For example, we can consider weight of the object or weight of the person who is standing in a stationary lift or a lift moving with the uniform velocity is same. This is an example. Okay, so example, weight of the body in the stationary lift or lift moving with a uniform velocity. whatever the force measured will be equal to the actual force acting on the body. The next one is non-inertial frame. Second one, non-inertial frame or frame of reference. What do you mean by non-inertial frame of reference? So here the non-inertial frame of reference means these are the frames in which Newton's first law is not valid. Okay? So these are the frames in which Newton's first law is not valid. It's not valid. Okay? And these frames are called non-inertial frames. What actually it means? How the Newton's first law is not valid here? So look here. Here in the non-inertial frame of reference, the measured force is different from the actual force acting on the body. Clear? Listen once again. Here in the non-inertial frame of reference, the measured force is different from the actual force acting on the body. Here, apart from the force applied on the body, the actual force applied on the body, one more additional force appears to be act on the body. Not actually, appears to be act on the body. Is it clear? And here the additional force which is appearing to be act on the body is called as fictitious force. It's called as fictitious force or a pseudo force. Right? Fictitious force, or you can also call it as pseudo force. Actually, it is not present, but it appears to be. The body will feel that the force is acting on my body. The body will feel that the force is acting on me. Okay? So, once again, in the non-inertial frame of reference, apart from the actual force applied on the body, there will be one more additional force appears to be act on the body, and that additional force which appears to be act is called as a fictitious force or a pseudo force. Okay? So I'll clear you this point with the examples. First example, let's consider a person who is standing in the lift, and the lift is moving downward direction with a certain acceleration, not uniform velocity here. Here I am not taking uniform velocity. Lift is moving downwards with a certain acceleration, accelerated motion. Then, what do you feel? So suppose you just imagine yourself will be in the lift which is moving in a downward direction with certain acceleration. Then what happens? Here, the body feels that its weight is lesser than the actual weight. Look here, whenever the lift is moving downward direction with certain acceleration, the person who is standing inside that lift feels that his weight is less than the actual weight. His weight is smaller than the actual weight, is it not? Okay? So here, look here, he feels he will be lighter than his actual weight. Okay? But when we consider in the uniformly moving lift, he feels the same weight as he has, as much he has. But here the lift is moving downwards with certain acceleration. Here he feels that his weight is smaller as compared to actual weight. Okay? This is an example for non-inertial frame of reference. One more example. Just you have to imagine yourself in a lift which is moving upward direction with certain acceleration. The lift is moving in upward direction with acceleration, with certain acceleration. Then you will feel that your weight is more than the actual weight of your body. Right? You feel that your weight is more than actual weight of your body. Is it clear? So, these two are the examples for non-inertial frames. And one more thing here, why the additional force appears to be act on the body? The reason is the additional force which appears to be act on the body is because of the accelerated motion of the frame. It is because of the accelerated motion of the frame. So here in examples, frame is lift where we have stood. Okay. So here the acceleration of the lift is responsible for whatever changes you will feel about your weight. The accelerated motion of lift is responsible for whatever changes you will feel in your weight. Am I clear? Okay, this is about a non-inertial frame of reference. And the next concept is linear momentum. Linear momentum. And you can denote it with the alphabet P. Okay? So simply we can call it as momentum, the linear momentum or simply momentum. What do you mean by the linear momentum? The linear momentum means it is the product of mass and the velocity of the object. Mass of the object and its velocity. Product of mass of the object and its velocity. It is the product of mass of the body and its velocity, right? It can be written as P is equal to M into V. M into V is equal to M into V. And here this linear momentum is the quantity associated with the moving body. It is the quantity associated with the moving body. It is the quantity associated with moving body. Okay? And here momentum depends on mass and velocity. Momentum depends on mass and velocity. Okay? So how? So look here, P is directly proportional to V, means velocity, when M is constant. When mass is constant. Okay? And similarly, P is directly proportional to M, means mass, when velocity is constant. When V is constant. V is constant. Is it clear? So here, next point, momentum is a vector quantity. Momentum is vector quantity. Means it has both magnitude and direction. Momentum has both magnitude and direction. So P is equal to m into P. In vector form, how can we write this one? In vector form, vector P is equal to m into vector B. P is equal to m into vector B. It is in the form of vectors. Is it clear? And here, the SI unit of momentum, SI unit. What is the SI unit? So, mass into velocity we have. What is the SI unit of mass? kg. And what is the SI unit of velocity? That is meter per second. Mass, kg meter per second. It is the SI unit of momentum. Okay. Then what is the dimensional formula for momentum? Dimensional formula. Look here. Kg means it is the SI unit of mass and dimension of mass is m. Okay. What is the power of kg? 1. So m power 1. Meter is the SI unit of length. What is the dimension of length? L. And what is the power of m? 1. And second is the SI unit of time. And what is the dimension of time? T. And what is the power of second here? -1. So here also -1. Is it clear? So it is the dimensional formula for momentum. And who introduced the concept of momentum means Newton. Newton introduced the concept of momentum. Newton introduced the concept okay, of momentum. Is it clear? Okay, next concept is Newton's second law of motion. Second law of motion. So here, first we need to study the statement of Newton's second law. So I think you are very much familiar with the equation or the expression for Newton's second law. That is F is equal to m into A. F is equal to m into A. It is the expression for Newton's second law. Then what is the statement of Newton's second law? So here it states that the rate of change of momentum of the body is directly proportional to the force applied on the body, and it takes place in the direction of applied force. Okay, so rate of change of momentum means linear momentum of a body is directly proportional to force applied on the body, and it takes place in the direction of applied force. What it means? So just look here, when you apply a force on a body, then obviously the body will get accelerated. Just imagine. Okay, when you apply force on a body which is moving uniformly with constant velocity, you are going to apply a force, then what happens is the body will get accelerated. Accelerated means its velocity increases. If its velocity increases, what will be the value of product of mass and velocity? Increases. Mass and velocity increases means obviously linear momentum, change in the linear momentum. Okay, So here rate of change of momentum also increases as the force increases. Is it clear? And that change in the rate of change of momentum will occur in the direction in which a force has been applied. Okay? In what direction force has been applied? In the same direction, the rate of change of momentum is going to take place. Is it clear? So we have the rate of change of momentum of a body is directly proportional to the force applied on the body. Force applied on the body and proportional to force applied on the body, and it takes place in the direction of applied force, and it takes place in the direction of applied force. Okay. So now, next we have the expression for second law, and it is very, very important. 3 months we can ask derive x is equal to ma for 3 months. Okay. So important. Derive f is equal to m into a. So we know that P is equal to m into v. Okay. So now solve this as equation number 1. Now dp by dt is what? That is the rate of change of momentum. Is it clear? dp by dt means a variation of momentum with respect to time. That is what? The rate of change of momentum. But according to Newton's second law, okay, F and the rate of change of momentum are directly proportional to each other. F is proportional to dp by dt. So in order to remove this proportionality sign, I will insert a proportionality constant k into dp divided by dt. Okay. So here k is nothing but proportionality constant. K is nothing but proportionality constant, and whose value will be equal to 1. And its value is 1. Okay? And the value of k is 1 unity here. So then F is equal to dp divided by dt, called as equation number 2. F is equal to dp by dt. Now we have the value of p from equation 1, and you need to substitute that equation 1 in 2. Right? Substituting equation 1 into we get F is equal to d by dt of m into v. But m is the constant mass. Mass is always constant, so we cannot differentiate that mass. So take it outside, and the variable here is v. So dv dt. The rate of change of velocity, what it means? Acceleration. So that is why F is equal to m into a. Okay. So because dv by dt is equal to acceleration. Is it clear? So I have to solve from there to here. Okay. Right now, the SI of force. The SI unit of force is Newton. Newton is the SI unit of force, and it will be indicated by the symbol capital M. The symbol capital M. And one more SI you can consider where mass means R. Alright, or mass SI is kg, acceleration is meter per second square. Is that right? This one kg meter per second square, or Newton. Most of the cases we are going to use. Most of the times we are going to use Newton only. So both are same. 1 Newton is equal to 1 kg meter per second square. Is it clear? Then how can we define 1 Newton force? 1 Newton definition. How can we define 1 Newton? 1 Newton means it is the force required to produce the acceleration of 1 meter per second square in a body having mass 1 kg. And look here, we have to get F value as 1. Then, at the RHS side, M should be 1 and A should be 1. Means acceleration should be 1 meter per second square and mass should be 1 kg. Okay? Then only we can get 1 Newton. So 1 Newton means it is the force required to produce an acceleration of 1 meter per second square in a body having mass 1 kg. Okay? It is the force required to produce an acceleration of 1 meter per second square in a body of mass 1 kg. Is it clear? Okay. So what the Newton second law and the force. But obviously you know that the force is a vector quantity. Okay. The next concept is Newton's third law. I hope all of you are familiar with this third law. For every action there is an equal and opposite reaction. Newton's third law. For every action there is equal and opposite reaction. Okay, so here I consider F as an action. Then reaction will be equal but opposite. That is minus F is the reaction. What it means actually? Just consider a swimmer who is swimming in a water. So here the swimmer used to push the water in the backward direction. Swimmer used to push the water in backward direction. That will be action. Then what happens? He used to move in a forward direction. Why? Because water used to push him in the forward direction. Water used to push him in a forward direction. So that is the reaction. The swimmer is pushing the water backward, that is the action, and water is pushing the swimmer in the forward, is reaction. So one example, and another example you can take the firing of bullet. When you fire the bullet, a bullet used to move in a forward direction, that is the action. And similarly, the gun used to travel in a backward direction, that is reaction. When you fire a bullet, bullet will moves in a forward direction, that is action. And similarly, that bullet, the gun will exert force on a bullet, so bullet moves forward, that is action. Then the bullet also exerts force on a gun, so that's why the gun will move backward direction, that is the reaction. So that's why usually when in the military training, the trainee used to tell for the students or the aspirants that they should hold the gun, which should be kept at their shoulder. Okay, that should be come to the shoulder, because when you fire, it will be get a rebound in a backward direction. If you hold that gun like this, then you may get injured to your face, or you may hold other than the actual posture, then you may get injured. So that's why the gun used to be held with the support of your shoulder, because it will rebound when you fire. So when the bullet moves in a forward direction, the gun used to travel in a backward direction. Okay. So this is about in terms of first law, second law, and third law, and the remaining we will discuss in the next class.